Alright, thank you for tuning in to another physics lesson with Mr. M. In today's lesson, we're going to be talking about apparent weight. So this topic usually falls within the force and dynamics unit as well, mostly because we talk a lot about weight. And so the idea or concept behind apparent weight is that your weight can change because your weight is actually a force, and that force is really dependent upon your acceleration. And so think of yourself maybe as being in an elevator. As that elevator accelerates upwards, you kind of feel a little bit heavier as soon as it starts to accelerate. Or if it accelerates downwards, you might feel a little bit lighter. And that's just because the acceleration will determine your weight. And this is represented by an equation. So our apparent weight is equal to the mass times gravity, so the actual, what we would consider the normal weight, plus or minus the mass times the acceleration. Okay, and it's plus or minus because if the acceleration is upwards, so if A is upwards, we add the mass times acceleration. But if A is going downwards, then we subtract. And this is an important concept. Knowing that if A is going upwards, we're going to add that additional force to the regular weight. If A is downwards, then we are subtracting. Think about it, if the acceleration is going downwards, it's like you're traveling with gravity, and so there's not as much pushing up on you. And then obviously if we don't have any acceleration, up or down, then we just have our normal weight, mass times gravity. Okay, and so the idea here is, when solving for apparent weight, they're going to give you the mass most of the time, typically, and we know what the value of gravity is. So the strategy is going to be solve for your acceleration and then plug it into this equation. And the way that you solve for the acceleration is you have to find the unbalanced force from your problem. Once you know the unbalanced force, you can divide it by the mass, and then thus solving the acceleration using Newton's second law. Once you have that, plug it right into this part of the equation, and if the acceleration is going upwards, you add. If it's going downwards, you subtract. Alright? And keep in mind though, this equation only applies to objects that are going upwards or downwards. There can be no left or right movement. There can be no angled movement. Only straight up or straight down. Okay, so let's take a look at an example problem. Let's say we have a 5 kilogram bucket. It's pulled upwards with an acceleration of 2 meters per second squared. What is the tension in the rope? So let's go ahead and draw our bucket. It's being pulled upwards. We want to know what is the tension. So if we were to draw a free body diagram, we would have the weight, and then we would also have the tension. Okay? And so the idea here is, what is the acceleration? It's 2. Our mass is 5. So our apparent weight, which is a force, our apparent weight is going to be 2 kilograms times 10 meters per second squared, because that's gravity. We are going upwards, so we're going to add the same mass, 2 kilograms, times our acceleration. So our apparent weight is going to be 20 plus 4. So our apparent weight ends up being 24 newtons. Well, you might have a little bit more of a difficult problem than this. This is a very simplistic problem. So let's take a look at how we would maybe solve for something a little bit more difficult. Let's say we have two connected objects, one on an incline, and it's attached to a hanging object. Okay? And they may ask you to solve for the tension in this rope that is connecting these two blocks. Well, the strategy that you're going to use is this block is either accelerating upwards or downwards. So you can use the apparent weight formula. Use apparent weight to solve for this block. So really, let's say that this was 50 kilograms, and let's say this was 10 kilograms. Well, we would know that this would obviously be accelerating downwards. So we would have a downward weight, and then we would have an upward tension. The equation that we would use, think back to your apparent weight equation. We're going to be accelerating downwards. So really the equation that we're going to be using would be mg minus ma. That's basically, when you solve for the apparent weight, you are going to be solving for the tension. And so your objective is going to be solve for the acceleration of these two objects. The way you're going to do that is write a net force equation. Your net force equation here is going to be obviously the weight minus tension, okay, and we kind of have that right here. But then you need to solve for all of your free body diagrams over here and solve for that net force. Once you have the net force, you solve for A, and then once you have A, you can plug it into this equation and solve for T. Okay, there's just the general idea here is, though, because this object can go up or down, we can use the apparent weight formula to solve for the tension in the string. Okay, well, hopefully this video is helpful for you in solving for apparent weight. Thanks for tuning in.